Hello friends, we are back with NCERT chapter 13 Motion and Time for class 7. Motion. When a body changes its position with respect to its surroundings, it is said to be in motion. Speed is the distance covered by an object in a unit time. Speed of objects help us to decide which of them is moving faster. Speed is equal to distance upon time. A moving car or a bus can travel at a higher speed when there is no traffic and slow down when there are traffic signals. Therefore, to calculate speed, we use the concept of average speed. Average speed is the total distance traveled by a body divided by the total time taken to cover that distance. Its units are meter per second, meter per minute, or kilometer per hour. Now I'll show you how to convert kilometer per hour into meter per second. 1 kilometers is equal to 1000 meters and 1 hour is equal to 3600 seconds. So we'll multiply 1 kilometer into 1000 and 1 hour into 3600. We get 5 upon 80. So to convert kilometer per hour to meter per second, we multiply the speed with 5 upon 18, and to convert meter per second into kilometers per hour, we multiply the speed with 18 upon 5. Rockets launching satellites into Earth's orbit often attain speed up to 8 kilometers per second. A tortoise can move with a speed of about 8 centimeters per second. Now we know speed is equal to distance upon time. So from this we can say distance covered is equal to speed into time, and time taken is equal to distance upon speed. Speedometer is the device that records the speed of a moving vehicle in kilometers per hour. It is installed in the front part of the vehicle or in the dashboard of the car. Odometer is a device that measures the distance moved by a vehicle. It is fitted along with the speedometer in the dashboard of the car. Now motion can be of two types, uniform motion and non-uniform motion. An object moving along a straight line with a constant speed is said to be in uniform motion. Examples of objects showing uniform motion include heavenly bodies, hands of clock, pendulum, etc. If the speed of an object moving along a straight line keeps changing, its motion is said to be non-uniform. Time. Now time is very important for everyone. Time is a phenomenon by which human beings observe and record changes in the environment and the universe. The standard unit of time is second. The smallest time interval that can be measured with commonly available clocks and watches is 1 second. Larger units of time are minutes and hours. In ancient times, when there were no clocks, early men measured time based on the periodic movement of the heavenly bodies, rotation and revolution. As time went by, certain instruments for measuring time were designed, such as sand clock, sundial, and water clock. Galileo Galilei's observation led to the development of pendulum clocks. Winding clocks and wristwatches were refinements of pendulum clocks. Nowadays, most clocks or watches have an electric circuit with one or more cells. These clocks are called quartz clocks. These clocks are much more accurate. A stopwatch used for measuring time in sporting events can measure time intervals that are 1/10th or 1/100th of a second. However, there are atomic clocks also that can measure time intervals such as microsecond and nanosecond. Such clocks are used for scientific research. Atomic clocks are based on the vibrations of atoms. This table shows the different units of time that are used depending on the need. 1 second is equal to 1 billion nanoseconds. 1 second is equal to 1 million microseconds. 1 minute is equal to 60 seconds. 1 hour is equal to 60 minutes. 1 day is equal to 24 hours. 1 year is 365 days. 1 decade is 10 years. 1 century is 10 decades. 1 millennium is 10 centuries. We will now discuss the working of clocks. Clocks and watches are based on the principle of periodic motion. Periodic motion is a motion in which a body repeats the motion at equal intervals of time. Heavenly bodies in space show periodic motion. One of the most well-known periodic motions is the to and fro motion of a simple pendulum. A simple pendulum consists of a small metallic ball or a piece of stone suspended from a rigid stand by a thread. The metallic ball is called the bob of the pendulum. You can see from the figure. The pendulum is said to have completed one oscillation when its bob, starting from its mean position B, moves to A, then to C and back to B. The pendulum also completes one oscillation when its bob moves from one extreme position A to the other extreme position C and comes back to A. The time taken by the pendulum to complete one oscillation is called its time period. The time period does not depend on the mass of the bob. However, it increases with the increase in the length of the string. Now we'll study the distance time graph. It is a line graph. In a graph paper, two perpendicular lines are drawn. The horizontal line is called the x-axis and marked as OX, and the vertical line is called the y-axis. It is marked as OY. The point of intersection of OX and OY is called the origin O. Only positive values are shown along OX and OY. Let us suppose a car is moving at a constant speed on a straight road and it covers a distance of 1 kilometer every 1 minute. The distance traveled by the car is shown in the table. On the graph paper, we draw two perpendicular lines. The horizontal line is the x-axis marked by OX and the vertical line is the y-axis marked by OY. We will show the time in minutes along the x-axis and the distance in kilometers along the y-axis. We'll choose a suitable scale to represent the distance and the time on the graph. Here the scale for the time is 1 minute is equal to 1 centimeter, and for the distance the scale is 1 kilometers is equal to 1 centimeter. We will plot the points corresponding to each value on both the axes for time and distance covered. On joining all the points, we obtain a straight line indicating the car has moved at uniform speed. Generally, the choice of scales is not as simple as in the previous example. We may have to choose two different scales to represent the desired quantities on the x-axis and the y-axis. Let us try to understand this. The distance covered and the time taken by a bus are shown in the table. We will show the time along the x-axis and the distance in kilometers along the y-axis. Now, the total distance covered by the bus is 80 kilometers. If we decide to choose a scale 1 kilometer is equal to 1 centimeter like in the previous example, we shall have to draw an axis of length 80 centimeters, which is not possible. So here we will choose a different scale. For time, the scale is 30 minutes is equal to 1 centimeter, and for distance, the scale is 10 kilometers is equal to 1 centimeter. We will plot the points corresponding to each value on both the axes for time and distance covered. On joining all the points, we again obtain a straight line on the graph, indicating that the car has moved at uniform speed. If the distance time graph is a straight line, it indicates uniform motion, or that the object is moving with a constant speed. If the speed of the object keeps changing, or if it displays non-uniform motion, then the graph can be of any shape. If the distance time graph is a straight line parallel to the x-axis or the horizontal axis, it means that the object is stationary. Thank you for watching the video. If it is of any help to you, please like the video and subscribe the channel for more such videos.